All right, so hello everyone. This will be the fourth video in this series of group training on figure work. And in this fourth video, our focus are case studies. So I will actually talked about the behind the scenes story of three figures that I've created over the past few years. There are two things I want to focus on. The first thing is I want to re-emphasize the main concept of uh, behind all the videos I've just created, which is we want to use the figure to directly tell a story and convey this information with our readers so that we can really help the readers to better appreciate the work that we are doing. And the second thing I want to do for this particular video is to just talk a little bit about one thing that we didn't resolve in the previous illustration video. So why do you want to, practice how to draw a good illustration, right? You might think that, you can get away with a lot of the journal publication by just taking good pictures of your experiment. That's actually true. If you are able to change the setup, get a good background for your experiment, you sometimes can get very clean, very nice looking figures, and that's enough for even the top tier journals. But there are also like a lot of situations where if you don't know how to do illustration, you actually struggle. And today we're actually going to talk about a couple of those situations. So let's get started. The first case, this is actually for a proposal the first figure of a proposal that I draw when I was still a PhD student. So this is not the final draft, but I guess it shows you a deep concept it's good enough to show you the concept. So what we're trying to do here is to create a micro origami, which is what I do for my PhD study. So I've already have some good work. So these two blue dots are from my first 2 years of a PhD research, created a micro origami, and we now want to push it forward. And we want to request funding from the federal government to support this exciting project. So the main idea is that if you look at the robotic arms that's being used in real, manufacturing world, we're talking about this industrial robotic arms, they typically have many active degrees of freedom. So basically the amount of joints you can control individually to achieve motion. But in the micro world, when your size of manipulator is very small, so there is this axis of the size of manipulator, um, it's extremely difficult to achieve multiple actively controllable degrees of freedom. So prior to our work, so this is published in 2020, the PhD, typically you have just one active degrees of freedom. So you can create very small micro origami that can generate very cool motions, very exciting. Um, but all these creases they fold at the same time. So you can fold this crane. This is about 800 micron long, very small. It's doable, but you don't have a lot of active degrees of freedom. You cannot create a dexterous robotic arm like those you use to, say, assemble your car, right? And some of our work has pushed us from one to two and three. So with that in mind, we really want to explore whether or not we can, push this further to larger active degrees of freedoms, and still maintaining the size of these actuators to be relatively small. So in this case, you kind of have to draw things, use the illustration skill, drawing skill we learned in the previous video, to create something. And because you haven't done it's a proposal, you haven't done any experiment yet. You don't have a good picture for it. You have to draw the illustration yourself. So in this situation, you find if you practice your skill during your PhD, once you become an assistant professor when you're working on your first proposals, the skills really connect very well, and that's something I definitely want to share with you. So that's the first case study, first figure, and let's move on to the next one, which is from one of the review paper I drafted when I was I think this is when I was graduating as a PhD and during the first year of my postdoc. So it's really to address one of a concern from a reviewer. So the reviewer um, look at our work and find disappointing that although we've given a lot of description of all the different origami simulation methods out there, we haven't really, tell people how to select and what are the key things we need to consider when developing an appropriate origami simulation. So it's less useful in that sense. It's a valid concern, and therefore we want to address it. So the way I address this is creating this full figure to describe what are the characteristics we want to consider when selecting the simulation and how the simulation objective actually, um, you know, um, influence our decision process. So a couple things you can notice. Do want to just recap some of the concept we learned. If you go back to the first video, we're talking about a composition of this figure, right? So you can guess this is probably a figure which is going to occupy the full width of the page. And then since it's occupying the full width of the page, we're using these four column setup. So each of these column is roughly a quarter of the page, which is 2 inch wide, right? So, and in this, if you use the setting and if you use the 8 point text, this will blend in with your final paper very, very well. And there's a bunch of illustration here, and the reason why I included this illustration into this figure is because I really want to create some visual connection that can help my reader to remember some of the key publications in the field of origami simulation. So these are actually figures. If you read a lot of origami simulation papers um, before this review is published, you probably bump into one or two that you actually can recognize um, from this figure. So that's actually the goal. We want to enable the readers to visually connect what we're talking about with the papers they've previously read. And sometimes when you use the figures from published papers, you typically are able to do it. You can request the rights to reuse their figures, and the publisher actually provides you a link. You just pay sometimes a couple, it's between $80 to let's say $200 per figures. You pay the fee and then you have the copyright to reuse them. Right. So, um, but in this particular situation, because many of these papers, the figures are probably from different um, papers, and if we directly use their work, the background is different color. Um, just imagine that there's a big block of black background. It's going to be very distracting for a figure like these. So in this case, the illustration skill that I talked about in the previous video is very handy. It helped me to create all these figures. I don't need to worry about a lot of those copyright thing because I'm tracing what's out there, redrawing them myself, and this actually counts as my work. But it also helps to achieve the goal of reminding the readers of many of these key publications out there. So, and we can use the same color for the panels, which maintains that visual integrity. So, everything connects, and this is really a good skill. And it's really one of those situations where creating an illustration is really, really helpful. And again, also, this figure also tells the story pretty well. So, it's actually a flow chart type of figure. So for instance, when you're trying to select the origami simulation, there's these three items you want to consider. Um, Actually, there's four, sorry, there's 2.3 here. So all of these components are in a descending order. So that's kind of how you can use it. So visually, they are grouped. All right. And then the last figure I want to talk about is this one. You've already seen it. It's a paper just published last year in Nature Communication. We're doing some of these experimental study of an origami deployable bridge. So this is the first thing I want to talk about in this figure is like why do I want to use my illustration skill to create something like that instead of using a nice figure or a nice picture from my experiment. I'm just not able to get a nice picture in this case. So this is a shared lab in of civil engineering labs. Typically don't look very clean, and we aren't able to set up any sort of black cloth or white background here. There's going to be people walk. It's actually a corridor. It's a shared facility, so people will be walking behind this testing machine over and over again. And there's all these wires flying around, and one of the sensor strain gauges S1 is actually located right behind this hydraulic actuator. So you aren't able to show all of them, right? So in this case, you kind of have no choice. You have to create a good illustration for yourself to just make sure that the figure is not distracting the attention from your reader, and we show clearly where the strain gauges are located, S1, S2. We use the colors to maintain so S2 is actually at the bottom, to maintain a visual, identity, to maintain that visually these informations are grouped together when you compare subfigure A and subfigure D. So the orange are S1, that's S1. And it kind of also automatically tells you a story, right? We also develop a simulation for these in this particular paper. And the simulation is this bold line. The experiments are this center solid lines. They match with each other very well when we are looking at the relationship between the strain and the applied forces. So that's one important thing we want to tell, which is our simulation is accurate, right? So this actually does the job pretty nicely. So we use the exact testing loading machine to test also these column. Once we salvage these device and reuse it as a column. And um, again, for the same reason, because the background is very distracting, I used the illustration skills from the previous video to draw this figure so that I get a clean background. I can lay out where the force is applied. I can put down the scale bars in a very clean and nice manner. And also this figure also blends into the rest of the subfigures nicely. All right. So in addition to that, the other thing I hope to just re-emphasize is, again, this figure is following that four column kind of configuration, composition. Each one of the subfigures about 2 inch wide. And then um, part A gets wider because it needs to get wider because of configuration, but then part B and E is a little bit shorter because it's a column configuration. So we've kind of already talked about this in the composition of video. Just want to re-emphasize that. And also just re-emphasize that using colors to achieve these visual grouping. And now that I'm looking at it, I actually feel that there's something I can improve after a year of the paper being published, which is these two color it might be difficult to differentiate between them um, when I'm using the grayscale. So if I'm plotting this in a black and white manner, I probably want to use the different line shape. So I probably want to say set the S2 to be dotted lines to maintain that visual grouping effect. And for this little circle here, but again, I have the S2 as a secondary help to as a secondary marker to help differentiate the grouping. But then I can do one step further, which next time I probably should be doing using a dotted line instead of a solid line. But anyway, so that's the final cases I hope to share with you. Hope that this is a very good recap of what we've been doing and throughout this four videos and hope that this final video so just make it very clear to you that why we want to practice some of this illustration drawing skills, let's say preparing for a figure for the next group meeting or preparing a figure for a dissertation proposal or preparing a figure for my prelim exam. Right, so the skills don't, if you don't practice them, you don't get them, right? But hopefully, with the help of these videos, you can get started and keep making your skills on figure work better and better. And also, I hope that when you're reading papers, the elements, you can start noticing these elements I talked about during the previous four videos while you're reading new papers. Just try to apply this concept. Try to judge a paper's figure work by, whether or not the figure is really telling a story, whether or not it's clear, whether or not it's clearly readable, like it's creating a good experience for you when you're reading them, right? So you can imagine that if I swap this subfigure A with this right subfigure there, I'm making all these markers and the scale bars here and there. It's gonna be very distracting, right? With this real experiment and with all the background and all the cables and all the obstructions from the hydraulic devices. You aren't able to see it as clearly and as cleanly as the one that I actually use in the real publication. So judge those judge the paper, just use this concept and judge the paper when you are reading them. That really helps you to get better at figure work. All right, so this is all I have for this final video. And thank you very much for your attention. I wish you have a great rest of your day.